So moving on to page 29, we're going to take a look at the piecewise defined function at the top. I know we already started some of the practice problems, so these should already be filled out, but we're going to go ahead and just take a look at another piecewise function for an example. So a little simpler here because we only have two parts, but we're going to go ahead and analyze what if we were to approach the left-handed side of -2 from this piecewise defined function. We don't have a graph for this one to actually check our answers, so we're going to have to go kind of off of our gut or our just base knowledge of these piecewise functions. So taking a look at -2, we got to figure out which constraint would work best. Now notice how both constraints or domains involve the value of -2, so we got to make sure we pick the correct one, and we want to choose the one that's coming from the left, meaning numbers that are smaller than -2. So that would fit this constraint, and we would then therefore use that piece or that equation. So direct substitution, go ahead and plug in -2. -2 squared is 4, times 2 is 8, and then -2 give us -6. So looks like as we approach -2 from the left, we approach a height of 2. Let's go ahead and check out the right-hand side. So we want to choose the constraint that has values bigger than -2. That would be the second one. So we'll use the second equation. Plugging in -2, we'll get 1 plus 1, which would be 2. So part C, notice, is asking us about the overall limit because there's no plus or minus. So to check the overall limit, we got to see if the left and the right would match and meet up at the same height. So notice how the left side is at a height of 2, the right side is a height of 2. Those match, so the overall limit must be 2. All right, now I do want to ask you, the limit as we approach -2 is 2, but what if I were to ask you about the function value at -2? So if you actually tried to plug in -2, what would you get out? So again, looking at your constraints, if you're trying to plug in a number, that means that you equal it, you're trying to substitute it in. And by looking at your domains, neither one of them have that bar. That means you can equal or include -2. So if there's no bar there, we are not possible or able to plug in -2 into either of those. That means the function value is undefined. Now with all this information, we should have a pretty good idea about what's happening graphically at this value of -2. If the limit exists, that means the left and the right side are meeting, but notice how the function value is undefined, so there's no closed point at where they meet. It would then therefore have to be an open circle, aka a hole.